Hello students, today we are going to do with the chapter that is elasticity. Now we have done the chapters moment of inertia, we have already completed with gravitation. So when you come with this particular chapter, there is, if you get to see the blueprint of your the contents, okay. Now in the blueprints of the contents, you will find that this chapter comes under the category of the it comes under the category of the nature of the materials of the particle, okay. That is what we have in this category, that in gravitation it was complete as a chapter as a whole, but when we talk of elasticity, then it is the mechanical properties of solids, okay. It is the mechanical properties of solids. So we are doing with the chapter where we are dealing with the mechanical properties of solid, as well as for the fluid also, right. So in this case, let us talk about elasticity. Suppose if I give you a steel wire, okay, its original length is, let us suppose, L, and if I give you a rubber, this is steel wire, and if I take off the same size another wire, and this is rubber, size is same for both. And let us assume you have given a force here. Let us assume this is the force that you have given here, and this force is of let's see, 2 kg weight for both, okay. So the same length, the same weight, that is 2 kg weight, but the materials are different. One is steel, the other one is the rubber, okay. Now what is being seen? It is observed that under the weight, the wire elongates. There is a change in the length of the wire. Okay, so what we really find to, if you, this is what is we call the deforming force. We call this as the deforming force. Okay, same for this also, deforming force. Now what you find that if you suppose if you remove the force, okay, the wire has been elongated under this, and if you remove the force, when you are removing the force, what is being generally observed, that let us assume this length was L, or L was equals to 100 centimeter. This is also L equals to 100 centimeter, right? So after the extension, let us assume the change in, this is the original length, let us take it as by capital L, and the small length L is 0.05 centimeter. So what is the next length? That is 100.0.05, and for here also let us assume it is 100.03 centimeter. Now when the deforming force is removed, what is being generally observed, that after the deforming force is removed, there is a restoring force coming into action, and this tries to regain the original size, right. So what it happens, as in due course it was extended up to 0.03, and after the deforming force, it, let us assume it is coming back to this particular part, or maybe less than that, maybe less than, because it is steel. And for the wire, let us suppose after the deforming force removed, the length that is coming at 0.02 centimeter, right. So you can see the difference. Here it is not able to regain its original site, and here it is only 0.001, very less. So we say that steel is more elastic than rubber. Why? Because here the steel has got the property to return back to its original size after the deforming force is removed. That is the condition for the elasticity. So what is elasticity? Elasticity is that property of the material due to which it is able to regain its original shape or size after the deforming force is removed, right. So that is what we call elasticity. If it is able to do it, we call the body to be elastic, and if it is not able to do it, we call the body to be plastic, right. Now there is a two things, physical quantity, that you need to understand: stress and strain. These are the two important things when you need to know. The whole chapter will just be moving around these two physical terms. What is stress? Stress is equals to restoring force by area. So here, what is the restoring force? This is the force which the deforming force is, and the restoring force is equal. So this is restoring force divided by area. That is what we call the stress, and its unit is, since it is force by area, so its unit, SI unit, is Newton per meter square, and its dimensional formula is m L minus 1 T to the power minus 2. That is, now when we call for the strain is the change in configuration by original configuration. Okay, the stress can be of three different types. It can be a tensile stress, it can be a, when we do have anything changes in terms of length, we call tensile. It can be bulk if it is in terms of volume, and it can be shear stress also when the position of the body is changed. We'll just deal with the shear stress little late. Same with the strain, we have got the change in configuration, maybe the shape, size, length, volume, whatever it is, it can includes all. It can be shape, size, volume divided by original configuration. Okay, now since suppose if we talk about the tensile strain, okay, so it is the change in length by original length. So if you are measuring it in a centimeter, it is also in centimeter, so it has got no dimensional, and the dimensional formula is ml0 t0, so it has got no unit, it has no unit. Okay, so I hope you must have understood about stress and strain and the basic property when to call the body to be elastic and when the body is said to be plastic. Okay, thank you.